Bismillahirrahmanirrahim. Assalamualaikum. So for this week lecture, we will continue chapter 3 with presenting the quantitative data. Okay, as I already mentioned in last lecture, there are two types of data. Okay, and uh, the table or chart that we can use to present the data for qualitative, we can use the frequency distribution table, contingency table, and for chart, we can use either bar or pie chart. Okay, and for this week, we will proceed with quantitative data presentation. So for quantitative data, for table, we can use the frequency distribution table. Okay, and the frequency distribution ni, we can classify the data into two types. Okay, either group data or ungroup. Okay, and then we got stem and leaf display. And for chart or graph, we have histogram, frequency polygon, and OGIF, right? And I believe you already learned about this previously during your school days, but maybe this one, stem and leaf display ni, you all tak pernah jumpa lagi. Okay, right, so we will go through this method one by one. Okay, so describing quantitative data. So quantitative data, everybody knows that quantitative data is data in the numeric form lah. Okay, data that can be expressed in number. And quantitative, there are two types of quantitative data or quantitative variable, discrete and continuous. Okay, that one we learn in chapter 1. Alright. So in presenting quantitative data, okay, we can present it as in group or ungroup. Okay, so if the data range is large, we present it in group. If the data range is small, we can present it as ungrouped data. Okay, so after this, I will show you what is the difference between group and ungrouped data. So therefore, there are two types of presenting quantitative data. Okay, so untuk table, so for the frequency distribution table, we have frequency distribution for group data and also frequency distribution for ungrouped data. Okay, and for chart or display, for ungrouped data, we can only use stem and leaf display. For group data, we can use either histogram, OGIF, or frequency polygon, right? So what is group and ungrouped data? So ungrouped data, we can, the ungrouped frequency distribution for ungrouped data, we can use to present the data that not involve data not in a large range. Okay, but if the data is in large, the range of the data is large, we need to group the data. Okay, for example lah, okay, let's say we have data regarding the number of siblings of students in a class. Okay, number of siblings. The number of siblings, let's say either number of siblings, then number of students. Alright. So number of siblings, let's say ada student yang ada one sibling, 2, 3, 4, 5 or 6. Okay. Banyaklah to 6. Let's say lah in that class, the student in that class either have one sibling, 2, 3, 4, 5 or 6 siblings, right? So for this data, we can present it as a frequency distribution for ungrouped data because the range of the data is small. Okay, range dia from 1 to 6 saja. So kita boleh present dia as ungrouped data, right? So number of student is the frequency lah. Let's say one siblings ada 2 student, this one ada 4, 8 students, 7, 6, ini katalah 3. Okay. So this is the frequency distribution for ungrouped data. Ungroup. Okay. So for the data that is in large range, we need to group the data. Okay, for example, let's say the amount of money spent by student for a day. Okay, let's say ada student yang do not spend money zero, ada yang spend sampai 100 ringgit per day. So range there is very large from 0 to 100. Okay, so in for this case, large range, we need to group the data. Okay, group the data. For example, we do like this lah. Okay, the data tu is expenses, daily expenses, okay, amount of money spent per day, and then the frequency is the number of student lah. Okay, so ada student yang spend 0 ringgit, ada yang 10 to 19, okay, let's say paling banyak is 50 lah. 30 to 39, 40 to 49, 50 to 59. Okay. So in this case, we group the data. Okay. So this is we call the group data. Okay, we group so we have here 6 groups lah. Okay, the first group is the student that spend from 0 to 9 ringgit. The second group is the student that spends 10 to 19 ringgit and so on. Okay, so this one you all already learned previously. So this is the difference between the ungrouped and group data. Okay, so for ungrouped data, we can present it as stem and leaf display, and for group data, we can present it as histogram or GIF or frequency polygon, right? So next, we will discuss stem and leaf plot. Okay, so stem and leaf plot ni easy je. We have quantitative data. Okay, so the numeric data, we divide the number or the digit into 2 parts. Okay, we divide the digits into 2 parts. The first part will be the stem, and the second part of the data will be the leaf. Okay, so the second part of the data or the leaf is the last digit of the data. Okay, leaf 2 must be only 1 digit, and the front part of the digit, the stem boleh jadi 1 or more than 1 digit. Okay, but leaf only 1 digit. Okay. So this plot is widely used in exploratory data analysis. Okay. So advantage of stem and leaf display. They provide us with the summary of the data, and at the same time the value of the data too is remain. Okay, we still know the value of the data, and we also know the summary of the data. Okay, for example, let's say we have this data, the attendance of student for 20 days in a class of 40. Okay, so we have this data lah. This data is already arranged. Okay, ada hari yang 26 students attend, ada yang 27, 29, 30, 32 and so on. Ada juga hari yang all students the attendance is full. Okay, all 40 students attend. Okay, so we have the data of attendance for 20 days, right? So to plot a stem and leaf, we need to divide the digit into two parts, the stem and the leaf. Okay, sorry. Here, the typing error, sorry. Okay, so for example, let's say the data is 40. Data is 40. So we did. Okay, so we divide it into two parts. The first part, the digit 4 will be the stem, and the second part, the digit 0 will be the leaf. Okay, so each of the data here is a 2 digits data. Okay, semua data ni 2 digits. So we divide it into two parts. The first part, the stem 2 will have 1 digit, and the second part will leaf 2 mesti 1 digit, right? So next, we group the numbers with the same stem, okay, with the same stem, and then list the stem in numerical order. Okay, so kalau kita divide into two parts kat sini, kita ada the stem dia 2, smallest is 2, and then 3, and then 4 lah, 4 for 40, right? Okay, so the stem we have 2, 3, and 4. And then we list the okay, we list the stem in numerical order. Okay, so dekat sini dia punya, kita mesti arrange dia from smallest to largest lah. Okay, smallest to largest. And then after that, we write down the leaf. Okay, the leaf also must be in order. Okay, in order from smallest to largest. Okay, so for 20, we have 26. So the leaf is 6, and then 27 and 29. Okay, 26, 27, 29. And then for 30, we have 30. 30 ada dua, 2 30s. So we must write the 0 2 times lah. Okay, because we have 2 30. Okay, so 30, 30, and then 32, and then we have 2 33, 3 3, and then 35, 37, we have 3 37. So 7, 3 7, 37, 37, 37, and then we have 4 38. So 8 8, 8 8, okay, 38. And then we have 239. Okay, and for full attendance, we have 240s. Okay, so 0 0. Okay, from this display, this stem and leaf display, we can we can see the distribution of the data. Okay, we know the distribution of the data. From this, we can see that most of the day, the attendance of the student is between 30 to 39 lah, meaning that at least one student absent, okay, for most of the day. Only 2 days saja yang ada full attendance, okay. So most of the days there are at least one student absent. Okay, so from this display, we know the distribution of the data. We can see it roughly, and we also know the value of the data. Okay, if the student absent, how many student absent? Okay, if the data is 35, we know that there are 5 student absent lah. Data is 39, we know that there are 1 student absent. Okay, we know the value of the data and also the distribution of the data. Right, so itu advantage dia for stem and leaf display, because the value of the value of the data is not is also there when we transform it into the display, right? So this is the frequency distribution, okay? So we can present it as group or ungroup. Okay, so this is a method how to construct the frequency distribution for group data. Okay, so for group data we have the classes. So sini kita panggil the class. Okay, so this is the frequency lah. The second column is the frequency. So this is the class. So to present the data in group frequency distribution, we need to identify or determine how many class do we need. Okay, how many class and how large is the class size, right? So this is the method how to construct the frequency distribution for group data. Okay. First, the number of classes. First, we need to identify the number of classes. Okay, so to identify the number of classes, we calculate the K. K, the number of class K equal to 1 plus 3.3 log N. Okay, this is the formula, 1 plus 3.3 log N. And then if we get the answer is in point form, so we round it lah, okay, round up into a discrete number. And then the second one, we determine the class size. Okay, class size. So class size equal to largest value minus smallest value. Okay, or largest data minus smallest data over K. K that we get in step 1. Okay, the number of classes. Okay, and then class limit and class boundary for each class interval must be identified. Right. So this is the guideline. Class interval should be mutually exclusive. Okay. And then the class intervals are of equal width. Okay, mutually exclusive, equal width, and the number of classes ni should be 5 to 15 tu is okay lah. Okay, less than 5 sikit sangat, more than 15 is banyak sangat. Alright. So for example, let's say we have this data. Okay, the time in days of development of yeast on 20 breads. Okay, so this is the data. So first step, we need to calculate the number of classes. Number of classes 1 plus 3.3 log n. Log n tu is the number of data. So we have 20 data here. We have 20 data. So n is 20 lah. So 1 plus 3.3 log 20 equals to 5.29. We round it up. So it becomes 6. So our table nanti we have 6 classes. And then we calculate the class size. Class size largest data minus smallest data. So largest, we find what is the largest data. So largest is 34. Smallest data is 3. Okay, so 34 minus 3 over k. K tadi we get 6. K equal to 6, alright. So over 6, so we get equals to 6. Okay, our class size also equals to 6. Okay, and then we define the class interval. Okay, class interval. Let's say I started with 3. You also can start with 1 or the closest number to the smallest data lah. Okay, smallest data is 3. Boleh start dengan 3 or other number. You nak start with 1 ke, with 2 ke, also can. With 0 ke, also can. As long as nanti the interval tu can fit all of the data. Okay, let's say I start the first interval with 3. So size dia mesti 6. So maksudnya 3 to 8 lah. Okay, 3 to 8. So the size is 6. 3, 4, 5, 6, 7, 8. Okay, so 6 size dia. And then the next class 9 to 14. And then 15 to 20, 21 to 26, 27 to 32, 33 to 38, the last class. Okay, so the last class is 33 to 38. So we must make sure that the largest data, 34 tu, can fit into the table. Okay, so 34 tu boleh masuk dekat sini lah. 33 to 38, 34 kan. Okay, so kita ada kat sini 6 classes. Okay, 6 classes. And also the size of the class is 6. Okay, each class tu size dia is 6. Okay, and then bila kita dah ada the class interval, next we find the number of observation or the number of data that falls in that class. Okay, from 3 to 8, kita kira lah ada berapa data kat sini, value dia 3 to 8. So sini 1, 8, 1, 2, 5 ni, and then 6, 3, 5, 4, and 3 here. Okay, so ada 5 data, value dia 3 to 8. Okay, so frequency dia 5. And then tengok berapa observation, value dia between 9 to 14. Okay, and then we write down the frequency. Okay, so complete lah our frequency distribution. Okay, so from frequency distribution of group data, next we can present it as chart. Okay, chart, we have histogram. The first one, histogram, is similar with bar chart, but the bar is next to each other lah. Dia mesti rapat. There is no gap between the bars. Okay, so this is the histogram. So for histogram, X is the frequency, X is the class boundary. Okay, X is the class boundaries and Y is the frequency. Okay, so let's say we have data, the weight gain. Okay, so this is the class interval, Okay, so this is the boundaries. Okay, so there is a difference between interval and boundaries. So this is the class interval ataupun limit lah, the class limit. So this is the class boundaries. Okay, boundaries ni is the midpoint between the limit, right? So for example, the upper boundary for the first class, kita ambil 6 plus 7 over 2. Kita ambil midpoint dia. So 6 plus 7 over 2 equals 6.5. So sini 6.5, 6.5. This one, 11 plus 12 over 2, 11.5. 16 plus 17 over 2, 16.5. Okay, so the boundaries is the midpoint of the class limit. Okay, the midpoint. Right. And then this is the frequency lah. So untuk x-axis is the boundary. Okay, so and this I generate using the Excel. Dia come up like this. So actually kita tulis macam ni lah. Sini 1.5. Okay, tak perlu tulis dalam bentuk range macam ni kita just label at the end of the bar. Okay, 1.5, 6.5, 11.5. Okay, ni tak payah 11.5. So here 16.5, 21.5 and 25.5, right? And Y is the frequency. Okay, so this is the histogram. And then from histogram, we can get the frequency polygon. Okay, frequency polygon. We just mark the midpoint of each bar and then we just connect it, right? So this is histogram. Just mark the midpoint. Midpoint dia punya center for each bar. Okay. But they must intersect dekat x-axis. Okay. Sorry. So this is how we get the frequency polygon, okay, from the histogram. And then we just connect the midpoint of the top of the bar, we get the frequency polygon. Okay, from histogram and frequency polygon, from these two display, we can see the distribution of the data. Okay, we can see roughly the distribution of the data. For example, for this data, we can see that most of the data dekat center ni. Okay, most of the data value tu dekat tengah-tengah area tengah tu. Okay, maksudnya most of the data between 15 to 11 to 16, alright? Okay, the last one is cumulative frequency curve ataupun OGIF kita panggil, right? So to draw cumulative frequency curve or GIF ni, we need cumulative frequency and also upper boundary of the class, upper boundary of each class. Okay, and we need to start with the class before the first class. Okay, class before the first class. Okay. So we already have frequency. This is the frequency. So next we identify the cumulative frequency. Okay. So sebenarnya the data given yang ni saja. This is the class yang kita ada from the data given. But we start with the class before the first class yang ni. Class before the first class because we want to start the cumulative frequency with 0. Okay. So we start the cumulative frequency with 0 and then the first class cumulative 2 and then the next class 14 plus 2, 16 and then 26 plus 16, okay, 16 plus 26, 42, 42 plus 12, 54, 54 plus 6, 60. Okay, so cumulative frequency dekat Y. Okay, cumulative frequency Y-axis. And then X-axis is the upper boundary. Okay, so kita ambil upper boundary the class before the first class, upper boundary dia is 1.5 lah. Okay, before tu dia punya upper limit dia mesti 1. Okay, upper limit dia 1. Jadi boundary dia is 1.5. The first class upper limit dia is 6, so boundary dia 6.5. The second the second class limit 11, boundary dia 11.5 and so on. Okay, so we start the upper boundary with 1.5, 6.5, 11.5, 16.5, 21 and the last one 26.5. Okay, so and then we plot the first class, the class before the first class, upper boundary 1.5, cumulative frequency dia 0. So dekat sini 1.5, 0. And then the first class 6.5, cumulative frequency is 2. Lebih kurang lah ya kat sini. And then the third class 11.5 and the cumulative frequency is 16. Okay, graf ni sebenarnya dia lari sikit. Okay, lari sikit. So saya erase lah erase. Okay, kita buat yang betul lah ya. Okay, 6.5 cumulative frequency is 2, lebih kurang kat sini 2. 11.5 cumulative frequency is 16, lebih kurang dekat sini 16. Upper boundary 16.5, cumulative frequency is 42, so lebih kurang dekat sini. Okay, then 21.5, cumulative frequency is 54. And 26.5, 60. Okay, and then we just connect the points. You nak guna ruler pun boleh, guna freehand pun boleh. Okay, so the shape dia lebih kurang macam tu lah, shape dia increasing. Okay, so yang ni kita panggil the less than ogive. Okay, ada two types of ogive, more than and less than. Okay, so less than ogive, we use the cumulative frequency and we only discuss the less than ogive. Okay, we do not discuss the more than. Okay, from ogive, we can estimate a few values using the ogives, like we can estimate the median, the quartile value, or the percentile value. Okay, and using the histogram, we can estimate the model value or the mode. Okay, for histogram. Right, so that's all for today's class. Okay, so we have finished chapter 3, the data presentation. Next, we will proceed with the tutorial. For next class, we will discuss the tutorial. Okay, so you will need to try out the tutorial first and we will discuss it during the next class. Right, so that's all for today. Assalamualaikum. Thank you.